It depends what you say test. I would say no, because then it would say something like that. Yeah. What do you suppose? That's an abbreviation.
Wait, is it quiz over vocabulary?
What does it say?
No,
Over like question problems? Or
those types of problems. Problem solving or problem quiz.
TZ?
Does that look like a Z? PQ. That's meant to look like a Q.
So what is it?
Problem quiz. Yep. Okay. We could look at it this way. Some of you are perhaps suffering because you have to listen to myself every day. How many of you see? This is another one of those things to where, honesty. So no, none taken. Okay, so at least not yet, maybe. I don't know. So here's your opportunity to say, I want to play teach. Who wants to play teach?
I've done that before. In Bickett. Yes.
Do you want to play teach again?
I got to teach Hannah say yes. Yeah, Hannah say yes. Oh, heck. What am I teaching?
I mean, I got to know because I can't have you on camera. That's why I say I got to know.
What am I teaching? The math?
That, yes.
Oh, sure. I'll teach.
Okay. Now you got to explain it as you go.
Okay.
All right? Okay. So let me make sure that I do this. See, you'll be on TV, so that's TV money. All right. Okay, so now that we got that solved, okay, a type of, let's say, diagram you could use as well, just like your conservation of momentum when two things run into one another, okay? Because what we're illustrating here is as follows, okay? Maybe this is the side of a building or something like that, okay? And then here's the ground. So then you're releasing your object here, and it's falling straight down for 3.7 seconds, okay? Because when you look at this label right here, okay, for every second that has elapsed, approximately how far has that object dropped in 1 second, do you think? In other words, it fell for what, 3.7? So here, got 1, 2, 3, and then whatever's left over there, which was 0.70. So after 1 second, because what are you doing with these two numbers? You're multiplying. So what's happening is after 1 second, it fell that far. What does it do in the next second? Okay. And what does it do in the next second? Okay. So when you multiply these two numbers, it's no different than adding these three together. Does that make sense? So here you're just showing what's actually happening. And maybe that helps you understand what's actually taking place here. Maybe yes, maybe no. But if that's the case, if you're sitting there thinking, I just don't get it, okay? You do have options. What are those options? Could be the Science Channel. You could ask for help from whom? Myself? An upperclassman? Maybe even another teacher? Okay? Because, because this would pertain, there's only three people that come to mind. One 2, actually 4, 3, 4. Okay? So of you 4, who should we pick on?
When? I already got picked on.
Okay? So chances are if you go, Preston, could you please help me with this? Chances are pretty good he'll help you. Okay? Then, since she was first, Kinsley, could you please help me with this? Chances are pretty good that would happen. Okay? Braden, could you please help me with this? Chances are pretty good. They'll probably help you. Carson, would you please help me with this? Chances are pretty good he would help you with this. Okay? I'm trying to think, did I miss any, or up here, I guess. Chris, could you please help me with this? Okay? Oh. Lauren, would you please help me with this? Maybe. Okay. And it doesn't even have to be that. You have a, where's my fly swatter? You have a bus driving trip up to Elkton. Is the junior high leave separately from everybody else? Okay. But if that was the case, if you rode with the rest of them, why did I say junior high? I don't know why I said that. Do you ride with the rest of the high school then? Okay. So, give me an example of a upperclassman volleyball player. Chances are pretty good. He said, Lainey, would you please help me with this? Chances are pretty good she'll help you. Okay? And
You just think everyone's so nice, Mr. McKinney?
I do. I'd like to give everyone the benefit of the doubt. Are we thinking that some of these people aren't? I don't know. Could be.
Siblings would never help us.
If you don't ask, of course they won't.
I asked Kristen the other night.
Yeah, they should offer.
And he said no.
Oh. Well, we have no control over all of that. Okay. All right. Middle row. Are we on the bus here? Front row. Back row. Okay? Everyone's doing this, so how do we interpret that on this end of the table? You're doing this so that you are telling myself that you understand this. Okay? But, again, you have a problem quiz tomorrow, and then you have an evaluation where you have another bite at the apple again. Okay. Can I erase this? You mean a formula sheet? I want you to be able to use that, not memorize it. Would it be horrible if you couldn't use it? Yes. Probably. No. Yeah. So, just like for the same reason, this could possibly be intimidating too. Next semester, I want you to know how to use this. I don't want you to memorize this. Certainly, yes, there's going to be certain portions of this you do have to memorize, but not the entire content of this. Because once you do that, you could say that it is sodium rhenium o'clock. Atomic number for sodium is 11. Atomic number for rhenium is 44. It's 1144, so it's sodium rhenium o'clock. That just comes with practice. What is 44? Ruthium, not rhenium. Darn it. Okay. Can I erase this?
Yes.
Okay. How many of you, if this was on your evaluation tomorrow, calculating an initial velocity, how many people would go, uh-oh, you cannot. You can use your formula sheet, and yes, I will be walking around. The only thing you should have on your paper is something like this. Of course, this and this. Other things you can have on your paper is that. You can have that. You can have this. You can have this. And I think that is it. Okay? So then we know this is mass. This is momentum. What's this one?
Meters over seconds.
And this one? Okay? And then, of course, with this, there's a question upon that. Acceleration can be 9.8, but it's not always 9.8. Does anyone think they know why? Because what did that problem deal with? It dealt with gravity. And how do you know you can use 9.8 for that? Not because we told you.
Well, I said gravity is 9.8.
Yeah. But how do we know that we're going to use 9.8? And don't say gravity. How is that object moving?
Means it's going down.
It's going in the vertical sense like this. Okay? That is why and how you'd use 9.8 for our purposes. But if something is moving in the horizontal plane like this, you do not use 9.8. You may have to calculate it. Maybe it's the two velocities divided by the time to give you an acceleration. Okay?
Wait, what's the difference between the one acceleration, the other, that one, and then the one that's A equals VF minus VI divided by time?
No, this is just saying that your variable acceleration is measured in meters per second squared.
Oh.
That's all that means. Okay? So, is there a difference between, okay, gentlemen, please. Okay? Is there a difference between momentum and conservation of momentum?
Probably.
There is. What is the difference? Does anyone know? Because you know the answer, you just don't know you know it. Okay? I use that all the time. Ask the upperclassmen that too. You know the answer, you just don't know you know it. What might the difference be? If a question was asking for the conservation of momentum on the paper that I'm going to collect, was there an extra added step to that?
Yes.
That's the difference. So what did you do with those two problems?
You had to subtract or add them or something.
One was right, one was wrong. Which one's correct? You subtract, okay? So typically what we say happening is if you have an object that's moving in this direction and an object that's moving in that direction, use A, B, or one of them was Sir Lancelot and King Arthur or something to that effect, okay? If this has, I'm just going to keep it simple, maybe this has 10,000 kilograms dash meter over second, and this one has 12,000 kilograms per meter over second. If we want to know the conservation of momentum, what is your extra added step for this? Okay? So that means this was conserved. Where did that 2,000 come from?
Subtracting.
Subtracting this number from that one, and that's where the 2,000 comes from. Then you would also state in A's direction. Oh, here we go. Chances are, physical science, good stuff, right? See, okay, hold up. If we said, find a friend. Find a friend in here. If Anya needed help, if Anya said, Anna, can you please help me with this? Chances are pretty good that what? Okay, see? It's that simple, people. Thank you. Okay. Anything else? Anything you want to ask, go over? Otherwise, to me, the rest of the time can be yours. I said I'm going to collect that in just a moment. Yep. Hold on. So there's nothing else? Going once? Going twice? It's sold. Okay, so problem quiz tomorrow.